you'll find some questions about how to add, subtract, and multiply matrices on the ACT. And as a bonus, I'll show you how to find a determinant of a 2x2 matrix. Okay, let's talk about matrices. First, I want to talk about adding and subtracting. First of all, when you add and subtract matrices, they got to be the same dimension. They have to be the same size and shape, bottom line. So let me give you an example of two matrices that are the same size. 1, 2, 3, 4. And then say we're going to add another matrix, same size, 2x2, 5, 6, 7, 8. All you really have to do is take the same corresponding position in each matrix, and you're going to add those two numbers, giving you the new or the resulting, the sum of those two. So you're going to take 1 and 5, giving you 6. Then you're going to take 2 and 6, add those, and that's going to give you 8. Take 3 and 7, that's going to give you 10. And then 4 and 8, and that gives you 12. And you're going to do the same thing. If this is a subtract, you would just take 1 minus 5, 2 minus 6, and so on. So adding subtracting matrices is not difficult. You might see one question on the ACT, so that's why I'm covering it. But the more difficult part, what you probably will more likely see, is multiplication of matrices. So let me give you a matrix at 1, 2, 3, and we're going to multiply it by a matrix that looks like this: 4, 5, and 6. Now the first matrix is a 1 by 3. The first number is your row. How many rows? By how many columns? The other matrix that I have here, well, how many rows does it have? It has 3 of them. And how many columns? It has 1. This is really important to know real quick, and I'll show you why you can eliminate a lot of choices on the ACT and almost just choose between 2. Narrow it down really quick. When you multiply these two, the inside numbers, these 3's, they have to be the same. They must. If they're not the same, you cannot multiply them. Then the outside numbers, that's going to be what the new matrix is going to look like. That's going to be your result, the product of the two matrices. So you know what it's going to look like. So if we take a 1 row, 3 columns and multiply it times something with 3 rows and 1 column, you're going to get a 1 by 1, just one term. So if you multiply these out, here's how it works. You've got to take the row first times the column. That's why I'm showing you just a row and a column. So you're going to take this row, take each number that corresponds, you take the 1 times the 4. So you're going to get 1 times 4. And then you're going to have to add, then you do the next set of numbers, 2 times 5. And then plus, and then you're going to do 3 times 6. And when you multiply and do all the math out, you're going to get 36. And it's going to just be one term, 1 by 1. I've seen a lot of questions. They like to give this kind of scenario, or they would have the first one, they would have this guy first. They would switch the order. And by the way, when you multiply matrices, you're not going to get the same answer if you switch the order in which you multiply them. And it depends also if the dimensions match up. So watch out for that. Also, one more thing. Let's talk about the last thing I wanted to give you a bonus on today. There's a possibility you could be asked to find a determinant. And I don't think they're going to ask you to find the determinant of a 3 by 3. They'll keep it simple. They'll probably give you a 2 by 2. And it looks like an absolute value, but you got numbers here. So I'm going to put A, B, and C, D here. The formula on how to find the determinant of a 2 by 2, all you're going to do is multiply down diagonally, so A times D. And then you're going to take and subtract the other diagonal, B times C. That's all you have to remember. So let me give you an example and just make sure you got how it works. Let me give you the matrix 1, 2, 3, 4. Just keeping the numbers simple. You're going to take 1 times 4, and then you're going to go minus 2 times 3. And that determinant gives you, well, let's see, that's 4 minus 6, giving you -2. That's all I think you really need to know about matrices. Add, subtract, multiply, and divide them. You might see a determinant if you're lucky.